Hello, students. Welcome back for another week of science, and this week is going to be an exciting week because this is the week we begin learning about the use of the Bunsen burner. That is our topic this week, and so I'd like you to open your books to page 88 if you haven't done so already. And we're going to begin today by working on our notes for the Bunsen burner topic. And we're going to begin by just briefly sharing, not that view, we're going to start by briefly sharing some information about Robert Bunsen. In fact, you probably watched this video on your own. If not, here's a hyperlink for you. You can check out that hyperlink on your own after the lesson. But the Bunsen burner is a device that was developed by our scientist of the week, Robert Bunsen. And he developed this device in order to produce a hot, efficient flame. In the days and years prior to Robert Bunsen's invention of the Bunsen burner, scientists would often do experiments where they had to use heat energy to heat things up using candle flames or little alcohol lamps. And these flames, although hot and certainly hot enough to burn you, did not and were not capable of producing flames hot enough to generate or facilitate certain chemical reactions and certain things from happening. Robert Bunsen knew this. And so he developed a rather simple device, which we'll be seeing here in a moment and we'll be utilizing throughout the year, the rest of the year, in order to produce a flame much hotter than a candle flame and much more efficient than a candle flame, meaning that it doesn't produce a lot of soot. And so let's look at our diagram in our book, and we're going to be labeling your diagram with the following parts of a Bunsen burner, because as we become more used to using these important tools in the laboratory throughout our study of chemistry, it's going to be very important for us to know the names of the different parts of the Bunsen burner like the back of our hands. Because if I ask you to, adjust your gas valve or close the collar, and you don't know what I'm talking about because you haven't studied and memorized the parts of the Bunsen burner, well, bad things can happen in the lab. So one way we can avoid those bad things from happening in the lab is to spend this week learning about the Bunsen burners and the different parts. So let's begin. So in your book, you should be labeling the different parts. Let's begin with the upper right, and we'll work our way around clockwise. On the top of the Bunsen burner, and by the way, I have a Bunsen burner right here in real life. These are the Bunsen burners we will be using in the lab, and I did my best. Here, let me turn it this way. I did my best to draw this on the smart board, so you'll have to apologize my crude diagram here that I drew, but I think it shows pretty accurately the main parts of our Bunsen burner. So here we have the barrel, similar to the barrel of a gun. You've got a something shooting out the end of the barrel. And in the case of a gun, you've got a bullet shooting out of the barrel. In the case of a Bunsen burner, you've got the flame shooting out the barrel of the burner. So this top cylindrical shape right here on the top is called the barrel. At the base of the barrel, you have a rotating device called the collar. So when I refer to the collar, when we're using the Bunsen burners, we're not talking about the collar of your shirt, but rather we're talking about this open cylinder here that rotates back and forth. This is the collar. The collar is basically a vent opening where you can open the collar and close the collar. You can open and close the openings there, which are the air intake. The next part for you to label on your diagram. The air intake are the openings themselves. For those of you that are into machines, engines, think of an internal combustion engine and the carburetor. In the carburetor of an engine, you've got the control of air intake that determines the amount of oxygen that can combine with the fuel. In a car, it's gasoline. In a Bunsen burner, it's natural gas or propane. But it functions in the same way. The collar provides you the ability to adjust how much oxygen is being combined with the fuel, which is coming out of a little structure on the inside called the spud. The spud is a tiny little opening. In fact, I'm going to disassemble my Bunsen burner here to reveal the spud to you. So if I remove the collar at the bottom of the barrel, remove that. Here we have a little device with a tiny little hole in it. That is called the spud. It's through that tiny little opening that the gas comes out of the tank, wherever it might be, and into the base of the Bunsen burner and up through that spud. So the spud is the tiny little opening, and you can control the amount of gas. Again, whether it's liquid propane, natural gas, you can control the amount of gas by using the gas valve. The gas valve is a knob that rotates back and forth. And as they say, righty-tighty, lefty-loosey. Righty-tighty, lefty-loosey. If you open your valve too much, that would be really bad to do while you were trying to light your burner. There's a rubber O-ring there. Don't touch it. But that rubber O-ring, you should never take out your gas valve so far to reveal or expose the rubber O-ring. Because if you do, there will be gas coming out of the bottom of the Bunsen burner, which could ignite right into your face or your hand. So if you see that little rubber O-ring, stop turning. Turn it the other way, righty-tighty, to close your gas valve. You don't want to open it all the way like that. On the other side is where we connect the gas tubing. The gas tubing is connected to the other side like this, and we'll go over those steps tomorrow. And on the very bottom of your Bunsen burner is the base. The base, obviously, at the bottom, just like last year with the microscopes, the bottom of the microscope is the base. Well, the bottom of a Bunsen burner is its base. It's all about the base, about that base. All right, so we've got the base where the gas tube connects, gas valve, the spud inside the air intake and the collar, and the barrel at the top. So make sure your diagram is correctly labeled, and make sure you study that diagram. Study that diagram, because when we get to use the Bunsen burner, you need to know the names of the different parts when I direct you to do something with your burner. So take that as a hint, by the way, for the quiz later this week. Study the diagram of the Bunsen burner. All right, now once we learn how to use the Bunsen burner and we get them lit, you're going to be producing different kinds of flames. In the laboratory, I'm going to refer to them as the bad flame and the good flame. The bad flame will look more like a candle flame. Now, I call it the bad flame because it is not as hot or efficient as, well, the good flame. It's more like a candle flame. It has a cooler temperature, and it produces a lot of soot because of the incomplete combustion that's taking place between the fuel and the oxygen. And I'll teach you how to make the adjustment on your Bunsen burner so that we can go from a bad flame to a good flame. Good flame has a blue flame. And in the laboratory, when we're learning how to use these, I'll dim the lights so that we can actually see the flame even better. And you will hear the roar of the flame as well. Because when we go from a bad flame to a good flame, the more efficient and hotter the flame, the louder the flame also is. So we'll be able to literally hear the roar of the flame as it is burning with a hot and efficient blue flame, which we will call the good flame. And it is about 3,000 degrees Celsius, so we're going to keep our distance from the good flame until we actually have to put something into it. We'll talk more about that as we get to each lab activity. So know the difference between a good flame and a bad flame. Now, before we even think about learning how to use Bunsen burners, we have to take a number of safety precautions because, as they say, an ounce of prevention is worth a pound of cure. Or what we really should say in the science lab is a gram of prevention is worth a kilogram of cure. That would be more appropriate with the metric system. So here's the deal. We're going to be going over some safety guidelines, some things that you will be required to do before we even begin setting up a Bunsen burner in the lab. So let's begin. You must first prepare your area. We are going to be dealing with producing a flame in excess of 3,000 degrees Celsius. That is a very high temperature, a temperature high enough that flammable material nearby can spontaneously combust if it reaches a certain temperature. So we want to make sure that our area is prepared, beginning with making sure that there's nothing on or under your table. So your tabletop and under the table have to be completely cleared of all debris. So we'll be putting everything in the safety cubbies over on the side of the lab so there is no flammable material laying around. Even little scraps of paper could be flammable material. A bottle of whiteout could be flammable material. Your little perfume bottle, if you've got that, that would be really, really bad. We don't want any potentially flammable material on or under the table. So don't just stack your books under the table, because if sparks shoot off, they can go under the table and ignite something down there without you even realizing it until your feet are aflame. So nothing on or under lab tables. That's just a general rule of lab safety. Number 2, check your clothing. Check your sleeves. If you've got long, dangly sleeves, not a good thing if you're dealing with chemicals or a Bunsen burner. Make sure your sleeves are at a comfortable length, like to your wrists where they belong. None of these sleeves where your thumb pokes out, not a good idea in labs. A regular shirt is the best type of shirt to wear. No hoods. Hoods and hoodies, never a good idea in the laboratory. Number one, it prevents your peripheral vision from helping you out. You don't want your view obscured. You're working in a laboratory with lots of other people. If something is going on at a lab table nearby, you should be peripherally aware that the fact that there's a fire breaking out and you might need to get out of the lab. No hoods. In addition, hoods that extend over your head like that, and hoods usually have strings, They can be dangling into the cone of heat around a Bunsen burner flame and could ignite. They could be, the strings could be dragging in chemicals, the residue of chemicals on the tabletop. No hoods. Hoods are not permitted. So no hoods on lab days. Strings, the strings I already mentioned. Jewelry, big dangly earrings or nose rings or necklaces. Don't wear them on lab day. If you have them on the day of a lab, that's fine. Take them off before you participate in the lab. Put them in your pocket, put them away, because oftentimes those metals that are used in jewelry could chemically react with the chemicals we're using. I don't want them to start dissolving your flesh later on in the day because you had jewelry that is slowly chemically reacting with some of the chemicals we use. So just don't wear the jewelry. Now, the only exception is a wedding band. Wedding band made of gold. Gold, as we will learn in chemistry, is pretty much chemically inert, which means it doesn't chemically react with other things, which is why wedding bands are made out of gold, so that they last a lifetime. So if you've got a wedding band, you can keep that on. But if you don't, all of your other jewelry should be coming off. Shoes. Shoes. You can't wear sandals in the laboratory. In fact, you can't have, in my laboratory, you cannot have any exposed flesh below the table. So I'll just mention pants here as well. You have to wear pants, no shorts. No shorts are permitted in the laboratory when we're working with chemicals or Bunsen burners. Your clothes are your body's first defense line if something were to happen. If you have a chemical spill or sparks shooting off, as may happen, you want your clothing to protect you. But if you've got bare flesh below the table, your skin is not going to protect you from the sparks shooting off the table from the Bunsen burner as we're performing experiments, and likewise with your feet. Your feet have to be covered. No bare feet, no flesh, no exposed flesh below the table, period. If you come to lab not prepared one day, then you'll be sitting out in the hallway and you will miss out on some really cool experiences. So always come to lab prepared, dressed appropriately. Next, if your hair is long, I'm not going to ask you to cut your hair off. No, 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 no. But I am going to ask you to put your hair back. For the same reason as strings and hoods on sweatshirts, long hair is a safety hazard in the laboratory when we're working with chemicals and with flames. Hair can ignite just as easily as a hoodie can ignite. And it stinks really bad. Those of you with long hair, if you've ever used a hair straightener or a hair curler and you've kept it on your hair too long, this is what will happen to you. It'll burn it right off and you'll have hair that looks like mine. No, just kidding. But if you've done that, you know how bad it stinks and you know that it's going to burn your hair right off. Even more so with a Bunsen burner, ladies and gentlemen. So if you've got long hair, you've got to tie it back. I would encourage you to have hair scrunchies, hair ties, something to put your hair back. I always have an emergency supply of unused hair ties in the laboratory in case you forget it one day. I have them back by the goggles, which we'll get to in a little while. But if you continuously forget hair ties of your own and you use up all of my emergency supply, well, the only thing left to tie your hair up with are elastic bands. And those of you with long hair know that that's the last thing you want to use to tie your hair back with because it gets stuck in your hair. Ouch, when it comes out. So put your hair back. Now, what is too long? Well, if you put your head down and you can see your hair, it's too long. Now, again, it's not too long from a point of view of style. it's too long for the lab. So if you put your head down, you can see your hair, tie your hair back, all right, for your safety and the safety of everything else. And again, I just can't emphasize this enough. Clear your floor. Even though I said earlier with number 1, clear the table above and below, I'm saying it again. Clear the floor. Nothing should be on a lab floor under the table. Nothing. So don't stack your books there. Don't stack your sweatshirt there. Don't put extra pencils down there. Make sure there are no scraps of paper down there. Whether you put them there or not doesn't matter. It's your responsibility right now before you light up a Bunsen burner to make sure your area is clean. So make sure the floor around you is clean. All right, now to more specific lab burner safety or burner lab safety. There are certain things that you've probably noticed in the science lab that we haven't referred to before, that we haven't seen before, that we certainly haven't used before. Well, now is the time. Today is the day. This topic is the topic where we have to make reference to these things. I need to point them out to you in case we would ever have to use them. My hope is that we will never have to use these things, but if we did, you need to be aware of them first. So let's begin with probably the most obvious thing, fire extinguishers. In the laboratory, we have 2 fire extinguishers, one in the front and one in the back of the lab. And these fire extinguishers that we have are rated for what is called both all of A, B, and C class fires. A class fires are those that involve paper or wood. Look around the room. Look at what your table is made out of. It's made out of wood, okay? Look at your book. It's made out of paper. We have the potential for class A fires. B class fires, class B fires, are those that involve liquids like grease, oil, flammable liquids. We're going to be working with those types of liquids in the laboratory with a Bunsen burner. And so we have the potential for class B fires as well. We also have the potential for class C fires. Class C fires are electrical fires. Look in front of you right now and you'll see electrical outlets. Those electrical outlets, when you plug something into them, allow the flow of electricity. So we have the potential for all classes of fire, A, B, and C class fires. And so we have fire extinguishers in the lab, and here's what they look like. You'll notice they are checked every year to make sure that they are up to date. There are instructions on them to stand back 10 feet, and you'll see that they are rated for all types of fires, A, B, and C. Here is the nozzle. That is the part that you would hold on to spray, and you would have to squeeze the handle after removing that safety pin. And that would be done after lifting up the fire extinguisher, and you can see how big it is. So that is the fire extinguisher, and hopefully we will never have to use the fire extinguisher. Let's move on to the next one, fire blanket. Now, in the back of the room, we have a canister that looks like this. That is the home for the fire blanket. To expose or release the fire blanket, there's a hasp on the bottom. You simply open it up, and the fire blanket comes out the bottom. You open it up and throw it on someone after you've opened it up to help extinguish the flames that they might be engulfed in. And remember those words you learned in kindergarten: stop, drop, and roll. So if you're near the fire blanket, you grab that fire blanket and you toss it around someone if they're on fire and encourage them to stop, drop, and roll. Next, we've got the emergency shower. The emergency shower is to be used only for emergencies. If you have a drastic case of BO, we will toss you into the emergency shower. No, I'm just joking. But If you were to be doused with a chemical, or you're in the front of the lab with near the emergency shower and you're on flames, you can certainly go into the emergency shower, which looks like this. It's labeled emergency shower. For your privacy, we have a shower curtain, which, by the way, will always be open on lab days in case you need to go in quickly. And there's a chain hooked up to a big old loop at the bottom. You go in there, you pull that chain, and you will get lots and lots of water pouring on you very, very quickly. Yes, it is cold. We don't have heated water. In fact, you wouldn't want heated water for an emergency shower because, as you will learn, a higher temperature it will facilitate a faster chemical reaction. So you actually want it as cold as possible. All right, that brings us to the eye wash fountain. In the front of the room, right near our emergency shower, is the eye wash fountain, which looks like this. And the eye wash fountain typically is covered, but it won't be on lab days. It will be uncovered, and you'll see the two yellow diffusers that you will place your face between. On the right-hand side is a lever that says push. You'll put your face between the two diffusers, open your eyes, and keep it in there for about 15 minutes if you get chemicals splashed in your eye. And that water comes directly from our well, from the groundwater, which remains about a constant 50 degrees year-round. So after 15 minutes, your face will be numb, but it's better than the alternative of being blinded by chemicals. The next thing that you need to be aware of is the main gas shutoff. There are two main gas shutoffs, one in the front and one in the back of the lab, and they look like this. And whenever we use the Bunsen burners, it will require me with a key to activate the gas. When that red light is on, you know the gas is on. Notice pushing the button shuts the light off, and you'll hear a loud click. That loud click that you will hear in the laboratory is the gas being shut off to the entire lab. But always remember there's residual gas in the lines, as we will discover when we start using the Bunsen burners. Now, again, before we even think about using burners or chemicals, safety first, and the easiest thing we can do to protect your face and your eyes is to wear goggles. Goggles will be the number one thing for us to do every week in the chemistry lab when we're dealing with either chemicals or Bunsen burners. And this is where you will find your safety goggles. In the back of the room is a cabinet labeled goggles. And opening up the cabinet, both sides are dedicated goggles for you and only you throughout the year. We do not share goggles. They are dedicated to you and only you throughout the year. And I will explain to you the distribution of those goggles and how you should keep them neat in your own individually labeled slot. And you are responsible for the care of your goggles and your apron as well, which is also in the same shelf as your goggles. So I've gone through that information rather quickly. On your own, you can watch this video on the Bunsen burner, but I would like to close today by emphasizing the importance of memorizing the different parts to a Bunsen burner in case I need to draw your attention. Not even in case. I will be drawing your attention to the different parts of the burner, and you will have to follow my instructions quickly. You won't be able to turn to your book and say, oh, what was the collar again? How do I adjust the gas valve? What's the gas valve? You need to know these terms before we use the burners. So your homework for today, no matter what else you do, is to study and memorize this diagram. So, with that in mind, I am going to say for now, bye.